this lesson, we are going to learn how to use the periodic table to name monatomic ions, specifically the cation. So we are looking at cation. Now, what are cations? Cations are basically a positively charged ions. And if you don't remember that, look at the letter T in the word cation. That T is very similar to the plus sign. So how do we name the cations? The name of the cations will take the name of the element. So basically it's equal to the element name. So for instance, hydrogen 1 plus, we have the same name as hydrogen. Lithium 1 plus, we have also lithium. Or magnesium 2 plus, which is also equal to magnesium. So we take the name of the elements on the periodic table. Isn't that easy? But there is one tricky part, and that is for the elements in group B. Because sometimes in group B, some of the elements will have more than one type of ions. For instance, copper can have Cu 1 plus charge or Cu 2 plus. So how will we name copper? We cannot just use the name copper and ignore the charges because the charge is extremely important. So therefore, what we use is use the Roman numeral. So Roman numeral. For instance, Roman numeral for 1 is I, Roman numeral for 2 is II, and 3 is III, and so on. In this case, if we look at copper 1 plus, that would be copper. So you notice how we take the name of the element, except we're adding something extra. In the parenthesis, we're going to put the charge. In this case, is 1. So the Roman numeral of 1. And then for copper 2, of course, we start with the name of the element, because all the positive ions take the name of the element. Therefore, we have copper. But to indicate this copper is 2 plus, we will put the Roman numeral 2. Now we look at the name copper 1 and copper 2. Copper 1 represent copper with a 1 plus charge. Copper 2 represent with a 2 plus charge. But how do you know which one is going to be the right one? Of course, we will give you the specific one to look at by using the name structure. And that's how we name cation. So again, look at the T in cation, and that tells you it's a positive ions. In the last lesson, we learned about naming cations, which are positive ions. Notice I didn't use specific type of element to determine the name of the ion, but I used the term cations, that is, a positive charged ions. Now in this case, we're going to use the term anions, which are used to identify negative ions. So here, we're going to look at the name of an anion. So anions are basically negative charged ions. Now, how do we name the negative charged ions? There are two things that we need to do. First, we drop the ending of the element on the periodic table. Second, after we drop the ending, we add IDE to replace that ending. So how does that work? We know that the majority of the anions on the periodic table will form a negative ions because all the elements from group 5A all the way to 7A, they all gain the electron to be stable. So let's look at those elements specifically. Here I zoom in. So first is in group 5A, where nitrogen. What is the ending for nitrogen? It turned out to be OGEN. So therefore we erase that and we put IDE. The ions for nitrogen would be nitrite. That is, when you have a 3 minus, we don't call it nitrogen anymore. Formula for the ions of nitrogen, which is N3 minus, this is called nitrite, not nitrogen. Then we go to phosphorus, which will form a P3 minus ion. So again, this is the formula for the ions. So what's the ending for phosphorus? It's turned out to be ORUS. And it's going to be, of course, at IDE, so we have phosphide. Then going down here, we have arsenic, which will also form a 3 minus charge, AS3 minus. And what's the ending for it? We're going to drop IC part. So therefore, we add IDE to it, and we have arsenide. Let's ignore the rest of the element down here on the bottom because they are exception to this rule. Then we go to oxygen, group 6A, which they formed are 2- because they gain 2 electrons to be that way, right? To be stable. So in this case, what's the ending for oxygen? Just like nitrogen. In this case, oxygen is YGEN. So we drop that, we add IDE. And the formula for oxygen ion is 2-. So when you see O2-, we would say oxide, not oxygen. What about sulfur? The formula for sulfur ion is 2-, but we don't call it sulfur ion. We drop the ending of sulfur, which is UR, and we add that IDE. So sulfide. So the formula for sulfide is S2-. And we also ignore selenium for now. Let's go over here. Here we have fluorine in group 7A, which they will gain 1 electron to be stable. An electron are negative, so therefore we have a 1- charge. What is the formula of fluorine when it becomes an ion? So of course, it's becoming F1- or just F- because we ignore the 1 all the time. So what's the ending for fluorine? It turned out is I and E. So again, we add IDE. Fluoride would be the name of the ions for fluorine. What about chlorine? The ending is also the same as fluorine, I and E, which means we have chloride. Chloride formula would look like this: Cl 1- or Cl-. Again, we sometimes ignore the 1. Then we have bromine, of course the same ending as chlorine and fluorine, and we drop that ending, we add IDE. And what's the formula for bromide, which is the ions of bromine? We have Br 1- or Br- only. And lastly, we have iodine, which is drop the same ending, so we have iodide. And what's the formula for iodide? It's basically I and 1- or just I-. What about for group AA? If we zoom out, remember this group is the stable group, and all the elements want to have the Lewis dot structure of the noble gas, which in this case, helium will look something like this, or the rest of the noble gas looks something like this, where they have a beautiful 8 valence electron. And that is the golden rule to be stable. And that's how you name negative ions on the periodic table of group A. In this case, we're going to learn how atoms can work together and bond together and function as a unit of ion. And these are called polyatomic ions. So polyatomic ions are basically a group of 2 or more atoms, okay, that are bonded together, but together they function as a single unit or a single ions. Here are some examples. For example, here we have hydronium ion. Basically, it's a group of 3 hydrogen and 1 oxygen, and they function as a unit with a charge of 1+. Here's another example. Ammonium. Basically, it's a group of nitrogen and 4 hydrogen, and together they have a charge of 1+ as well. And over here we have another example, which is hydroxide. Hydroxide is basically a group of oxygen and hydrogen, so we have OH-, or 1- charge. So not all of them are going to have a positive charge, some of them have a minus charge. Then we have another example. We have nitrate. Basically it's a group of NO3, which is 1 nitrogen and 3 oxygen, and together they have a 1- charge. Sulfate is a group of S and O4, so sulfur and 4 oxygen, but together they have a charge of 2-. Lastly, we have acetate. This one is a very complicated one, but overall it still functions as a unit of ion with a specific charge. So in this case, it is a group of C2H3, 1, 2, 3, O2 with a charge of 1-. Unlike the monatomic ions, the polyatomic ions are basically groups of specific atoms. As you can see, there are no specific pattern that we can use to determine the name and the formula for polyatomic ions. That's why I give you this list that you have to memorize it individually. However, there are shortcuts that we later will cover how to memorize these common polyatomic ions. But for now, you must know the name as well as the formulas for each of the polyatomic ions in order to be successful in chemistry. Let's go to the list. Here are two common positive polyatomic ions, and one of them is ammonium, the second one is hydronium. Those are the only two that are positive. And the rest are all negative ions.